Hi everybody, this is my lesson on pressure. So if you take a look at this man, you're probably wondering, how is he doing this? He must be in so much pain. He's lying down on a bed of nails. Wow. And I'm wondering if some of you even tried this. In the Science Museum, they have chairs, they call it the fakir's chair. If you're sitting down on a bed of nails, it doesn't seem to be painful. How is that? Well, yes, you probably guessed it right. Because he's lying down, his surface area is large, and so his mass is distributed across the nails. This is why it's not as painful. But if he stands on it, his entire body, the mass of his entire body is located directly on his feet, so the surface area is a lot smaller. This will make this a lot more painful. So the larger the surface area, the less pressure, as you can see here. And the best way to get off this would be to roll off slowly. Or if he sits up and then gets up, he might also have a little bit more pain than lying down like this. So basically, we look at pressure. It's the force exerted by particles when they collide with a surface. And indeed, this applies to gases as well. You have a lot of pressure in gases when you have particles of gases pressing against a balloon, for example, or any other container like a can. This also applies to liquids. Basically, any particles that apply a force against a surface, we'll call this pressure. So like you see in this image of the syringe, you press down, you're causing pressure on the inside. While on the inside is the liquid or gas that is being pressed is feeling this force and causing extra pressure on the surface like that. And so as you see in this blue box, a reminder is a force is a push or pull upon an object resulting from the object's interaction with another object. So gas particles, for example, they are pressing against the surface of this piston on the inside, or a syringe. So we can safely say that if a force increases, pressure increases as well. And if force decreases, pressure decreases as well. They are directly proportional. Now, if the surface area increases, like this man that's lying down on a bed of nails, the pressure will decrease. And the opposite is true if the area decreases. So if he stands up, it's only his feet as opposed to his entire body, the pressure will definitely increase, and he might get hurt actually. So the surface area and pressure are indirectly proportional, meaning as one goes up, the other goes down. And you see here I wrote as an example, that's why papers can easily give you a paper cut, because it's just one slim paper, one small surface area. So the pressure is all focused on that small surface area. You don't get a paper cut from holding an entire book, for example. And we look at this similarly for polar animals that live in an environment that has a lot of snow. We look at the polar bear paws versus the black bear paws. The polar bear has been adapted to live in snow, and this is true because look at his feet. His paws, he's able to stand in the snow without sinking too deep in the snow. And the black bear is not meant to live in polar areas, so he can sink in snow if he was to stand with his paws like that. We were inspired by this to create snowshoes. A long time ago, the native Indians created snowshoes made of wood and leather. Nowadays, there's all kinds of new materials that allow us to have snowshoes. But regardless, it's the same concept. You're increasing the surface area, and so you're distributing your mass, and this reduces the amount of pressure in the snow. So you can stand in the snow without sinking. Same thing happens in your kitchen with a knife. You will use a sharp knife because all of your strength, your force is focused on one small area. So this increases the pressure, as opposed to a dull knife where it is a wider space, wider area, meaning that the pressure is reduced. So you'll use a sharp knife to cut through steak, but you use a dull knife to cut through butter, for example, or any other soft food. And this sharp knife exerts a large pressure on the surface due to the small area of contact right here. The dull knife exerts a small pressure on the surface due to the large area of contact. And if you were to try to use a dull knife to cut through steak, you'll know that it'll be very difficult to do so. It is doable, but you have to put a lot of strength into it. And there's an actual equation that puts all of it together. As you can see, pressure is equal to the amount of force divided by the surface area. We'll take a second and look at atmospheric pressure. So I say the atmospheric pressure is like an invisible force keeping us all intact, so we don't blow up and our blood doesn't boil here on the surface of the Earth in the troposphere. So this pressure is exerted by the air. There are air particles surrounding us right now as we speak, and these are causing pressure all around us. However, we're not crushed by the atmospheric pressure because the pressure of the air hits us from all sides, which cancels out its effect. So meanwhile, you have pressure coming from the right, pressure coming from the left, so these two cancel out. And it's an equal amount of pressure because it is the same air that surrounds you. And this is why you don't feel right now, as you're sitting, you don't feel that you're crushed by the air, because it's the pressure of the air is canceled out because of all the directions. The time that you'll feel a difference is when you go up in the atmosphere, for example. As the altitude increases, the atmospheric pressure decreases. This is because you have less and less air surrounding you as you go up in altitude. And so this pressure difference, you will feel it in your ears. You start to feel your ears start to pop. And you feel that same thing in the airplane. As you go up in altitude, the pressure surrounding the airplane is reduced. And so this means the pressure surrounding you is reduced, and you'll feel a difference. And this is when your ears will start to pop. This is the main reason why if you let a helium balloon go off in the atmosphere, it will end up exploding. Just because there's nothing keeping the balloon together. There's less air, atmospheric pressure, causing the balloon to stay intact. So as it goes up in the atmosphere, the air that's inside of the balloon tries to escape. And this is why a balloon will end up inflating, so much so that at some point the balloon will pop. Yeah, this is what I just said. There's less air, so less pressure as you go up in the atmosphere. So we use various instruments to measure pressure. We have the barometer that measures the atmospheric pressure, especially used for weather. At the Weather Network, if you look at the websites or watch the news, they will tell you, today it's a low pressure system or it's a high pressure system. These pressure systems determine whether we're getting good weather or bad weather. Bad weather, such as rain, storms, that sort of thing, it's going to be a low pressure system. And we use a barometer right here to see this instrument will tell you. We use a manometer to measure the pressure acting on a column of liquid. This shows you the pressure due to various liquids. The tonometer measures pressure in the eye. So like you see here on the side, you have an image of a person that has pressure inside their eye. This is normal. But if there is a problem, for example, there's cataract or built up of fluid inside the eye, the tonometer can actually detect this difference in pressure. And lastly, we have units that we're using for pressure. Here in Canada, we use pascals. So the typical or standard pressure, I should say, is called is atmospheric pressure is 101.3 kilopascals. So at sea level, which means down at the troposphere, where we are located right now on Earth. And then you have other areas of the world that use various units. So the ATM, the torr, millimeters of mercury, or PSI. Depends. Just like you have for temperature, here we use Celsius, but in the United States they use Fahrenheit. So today, I hope you're getting a high pressure system with good weather and sunny day, no rain. And on the low pressure systems, perhaps next week it'll be raining. Have a good day.